Yep. All right, they'll settle down in a second. I promise, YouTube. All right, guys, here we go. Okay, did you have this far of the notes done from 9 to number 4?
Yes.
Okay, so we started 9 to number 4. I'm going to kind of preview that again, and we're just going to finish this problem and then be done with chapter 9 too. What happened here, because I know that you did not spend the whole weekend doing pre-cal stuff. I know you didn't just do binomial expansion all weekend and you didn't look at Pascal's triangle all weekend. That's okay. A reminder that we learned Pascal's triangle because it helped us find the coefficients when we did our binomial expansion. And every time we did binomial expansion, we took my exponents. And for the first term, we went down. So we started with the highest number, and then we went down by 1, down by 1, down by 1 until we had nothing. And then we took the other value, y, and then we went up by its exponent, 0, and then we went 1, 2, 3, 4, 5. Every single time, these exponents added together to equal my total exponents, and then we use the coefficients that came from Pascal's triangle, exponent we were looking at. Okay, so that's kind of just a brief of what we did last class. Now, last class we did start number 4, and I might have had this backwards. I might have had all 3s at front. It doesn't truly matter because it's a mirror image. But what happens is I looked at the opportunity of rolling a dice 5 times. So we looked at the binomial expansion of doing something to the 5th power. So that's where my 1, 5, 10, 10, 5, and 1 come from, because I did my binomial expansion, my coefficients from that. Underneath that, I thought about what's the opportunity that I could get a single number or anything but that. So we started with 3. So we're like, okay, we could have roll my dice 5 times and I could get 0 3s. And that means I would get 5 numbers that are not 3s. Then I could roll my dice and get 1 3 and then 4 numbers that aren't 3, et cetera, all the way down. So we counted it all the way down, and my no's were like anything but. So if it's 3, I could roll 1 or 2 or 4 or 5 or 6. I just couldn't roll a 3. What we did then is we would take the term we're looking at. So the first one said exactly 1 3. So I looked at like this spot right here. My coefficient was 5 because that's how Pascal's triangle works. My probability, or I was rolling 1 3. So my probability of rolling 1 3 is 1 over 6. There's only one side that's a 3. There are 6 total sides. So probability of rolling a 3 is 1 over 6. And we only wanted to do that 1 time. My probability of getting anything but a 3, so anything that's not a 3, would be 5 over 6. And I wanted 4 of my times I rolled the dice to be that. So I took my probabilities, raised them to the different powers. And then again, I had to use my binomial expansion coefficient from my Pascal's triangle. If you put that all in the calculator, we got about 40%, 0.4889 or something last period, about 40%. Now, you can do the same thing with no 2s. So even though I have my picture labeled with all 3s, 0 3s, 1 3, 2 3s, 3 3s, etc., I could relabel these and make them 2s. It doesn't matter which one. It's still the same percentage as rolling 1 2 versus 1 3. It's just a different side. This time I'm looking at what's the probability of me rolling 0 2s. So I'm going to look at this term right here. So again, I use my coefficient from before. It's just 1. This time I'm not rolling any 2s. So even though my probability to roll a 2 would be 1 over 6, I want 0 of those. I technically don't have to write that because anything raised to the 0 power is what? 1. So technically 1 times 1, that doesn't change anything. So really my only answer is the one that's in the box, which is the last part of this, which would be what's the probability of rolling anything but a 3? Well, that would be 5 over 6, and we want to do that for all 5 of my rolls. So 5 divided by 6, all raised to the 5th, and these are about the same number when you multiply it out. Okay, so we did that on Friday. Anybody have any questions yet? I know it's really hard to learn online, so I would go back and look at your notes, especially since your Chapter 7 test is coming up next. See if there's anything you missed because we were learning online. Go back, watch the video, come see me during office hours, come to Zoom tomorrow night, because I don't want being online for a week to really throw off your whole grade. Okay, so we're gonna do 2 more of these. It's the same process. I'm not gonna relabel anything, except this time I'm looking for no more than 1 4. So again, I know I have these labeled 2s and 3s. I can label them 4s. It's okay if you have 1 4, right? It says no more than 1 4. Is 1 4 okay? Yeah, can I have 2 4s? No. Okay, so 1 4 is okay. Can I have 0 4s? Is it okay to have 0 4s? Yeah, it just says no more than 1. So you can have 0 or you can have 1. So we're going to take both of these places, which we've actually already worked out kind of individually, and we're going to add those together to be the probability of getting no more than 1 4. 0 4s is okay, 1 4 is okay, so we're going to do both of these probabilities. So my first one is going to be my 0 4s. So my coefficient is 1. My probability of rolling a 4 is 1 over 6, but I want 0 of them, so technically you don't have to write that if you don't want to. And then my probability of not rolling a 4 is 5 over 6, and I want my 5 rolls to all be not 4s. This is literally the same work we just did in letter B. Now, that's not my only answer. I could also, it's also okay if I have 1 4. So again, my coefficient is 5. My probability of rolling a 4 is 1 over 6. It's only okay to have 1, so I'm going to have that to the first power. All my other rolls have to be not 4, so I have to do 5 over 6. And my 4 rolls must be that. You can always check yourself by looking at your exponents. 0 plus 5 is 5. 1 plus 4 is 5. So they should always add up to be 5, or whatever your total is. For sake of time, I'm not going to put that in the calculator and multiply out. That's just where we're going to leave it. Anybody have any questions yet? Okay. The last one, it says at least 1 6. Can I have 0 6s? If I want at least 1 6, can I have 0 6s? No. Can I have 1 6? Yeah. Can I have 2 6? Yes. 3, 4, 5. All of them can work except for 0. Now, I know it didn't take us that long, but it took us a minute to write out those 2 pieces, right? If I have to do that 1, 2, 3, 4, 5 times, that's going to take me a long time. Instead, the way probability works is it always comes from 1. The highest probability you can have is 100%. So I can, instead of doing all of the things that are okay, I can do 1 minus the thing that's not okay. Does that make sense? So I'm going to do 1 minus whatever is not okay, and I'm going to write my little like expression like we did up here with this guy guiding me. So it's not okay to have 0 6s in this case. So my coefficient is still 1. My probability of rolling a 6 is 1 over 6, but I'm doing that 0 times, so I can do 1 over 6 to the 0. Again, you could just skip that step if you don't want it. And then I'm rolling anything but a 6, which is 5 over 6 probability. And I'm going to raise that to the 5th power because all of my rolls, all 5 rolls should be that. And that's my answer. And I can put that in the calculator if you want. I can actually multiply this out if you would like. So 1 times 1 over 6 is 0. That just becomes 1. So I'm only going to plug 5 to the 5th divided by 6 to the 5th in my calculator. If I do, I should have put parentheses in on that. 5 over 6 all raised to the 5th power. Yep, that gives me about 40.0187. So I've got 1 minus 0.401877. And if I do 1 minus that answer, I get the probability of rolling at least 1 6, which is 50.5981. Or I can think of it as 59.8%. All right. Everybody cool with that? Okay. That is 9.2. I want to do definitions at the top of 9.3 really quick, and then we'll go to lunch. So we're gonna skip number 5. I can make a YouTube video on that because it's a lot like the one above it, or we can do it in office hours or online on Zoom, whatever, but it's very similar, and I just gotta move on and get more types of problems in with you guys. So the last thing I wanna talk about is, what does probability mean? What does odds mean? Probability, again, we've been doing this kind of over and over. I'm sure you've like learned about it at some point, but the official math definition is the number of successful outcomes over the number of total outcomes. The difference between that and odds is the number of success over the number of failure. So together they should add to be the total, but it's not just success over total, it's successful outcomes over failure outcomes. Again, they mean the same thing. We're gonna do a couple of quick examples. What happens if you flip a coin? Let's talk about what these two would be if we're flipping a coin. Just one coin. What's the probability of getting a tails when you flip a coin? 50%, right? Or 1/2. You can write it as a decimal, you can write it as a fraction, you can write it as a percent. All of those answers are fine. The odds, though, is the number of success over the number of failures. If we're flipping a coin and I want tails, there's one success, and then how many failures are there? One. The failure would be a heads. So you can write it as 1/1. A lot of times we see it as ratios too. I would not write it as a fraction or a percentage. I just would write it as 1/1 or 1/1. Similar for a coin, a dice. If we're using a dice and I say, okay, what's the probability of rolling a 5 on your dice? 1/6, right? There's only one side that's a 5 and there are 6 total sides. What's the odds of rolling a 5? Not 1/6, 1/5. Yep. I don't use odds a lot. Majority of what we use is probability, but I want you to know there's a difference. All right, we'll go to lunch. We'll come back at 12:16. We are going to finish as much of this as we can. Enjoy your lunch. So we're up. So again, we're going till 12:16, guys. If you want to get off Zoom and then come back, you are welcome to. I'm just going to mute me so you don't have to listen to us for lunchtime, okay?